All right, for this problem, we have in the circuit a real battery with EMF 6 volts and internal resistance of 2 ohms is inserted between points A and B. We can see this in the picture here. Our question is, what is the voltage difference between points A and B? And we're just going to be looking at the magnitude, and we're not going to be worrying about the positive or negative signs. So looking at our first picture here, that's our starting circuit. So what first thing we're going to do is we're going to find the equivalent resistance. To do that, we have these here. So for our first one, since they're in parallel, we're going to use this rule, 1 over 44 plus 1 over 77. So our equivalent resistance is 28 ohms. For the next one, it's we're going to get 30 ohms, and then for our last set of parallel resistors, we're going to get 40 ohms. Since in the question it says that the series is with a 2 ohm resistor, we're going to make sure we add that into our total. So we get 2 plus 28 plus 30 plus 40 ohms, which is equal to 100 ohms. You can see that we have it here. Next thing that we're going to do is we're going to find the current. So current is I equals V over R. So we have our 6 volts over our total equivalent resistance, which is 100 ohms, which gives us 0.06 amps. Next thing we're going to do is we're going to find the voltage that's going across the 2 ohm resistor. So down here we have 0.06 amps times the 2 ohm resistor, which gives us a total of 0.12 volts.
And the reason we can use 0.06 amps is because we know that the 2 ohm resistor is in series with the battery, which will give it the same current that falls to the battery. So then we know that you have 0.12 volts, and you have battery voltage minus the voltage drop of 2, the voltage drop across the resistor, the 2 ohm resistor, gives you the voltage fell between A and B, which is going to be 6 minus 0.12 volts, which gives you 5.88 volts.